guys, and welcome back to our channel Horizons Across. In this video, we will be exploring the wonders of metamaterial cloaking. Now, the first question is, what is metamaterial cloaking? Or before answering that, let us see what do we mean by metamaterial. The prefix meta indicates that the characteristics of the material are beyond what we see in the nature. This means that these materials are artificially crafted composite materials that derive their properties from internal microstructure rather than the chemical composition found in natural materials. Moving back to our question, what is metamaterial cloaking? The simplest answer one can give is the usage of metamaterials in an invisibility cloak. Have I caught your attention? Well, stick till the end to learn more about the famous invisibility cloak. Let's proceed. The primary reason for the intensive interest in metamaterials is their unusual effect on light propagating through them. Metamaterials consist of periodically or randomly distributed artificial structures that have size and spacing much smaller than the wavelengths of incoming electromagnetic radiations. Essentially, each artificial structure functions as an atom or molecule functions in normal material. However, when subjected to regulated interactions with electromagnetic radiation, the structure gives rise to entirely extraordinary properties. Here comes an interesting fact. Did you know? Some naturally occurring materials such as opal and vanadium oxide do exhibit unusual properties when they interact with an electromagnetic radiation and therefore have been named natural metamaterials. Now, speaking of extraordinary properties, an example of such extraordinary properties can be seen in the two fundamental parameters that characterize the electromagnetic properties of a medium. A. Electric permittivity and B. Magnetic permeability. Electric permittivity is a measure of tendency of the electric charge within the material to distort in the presence of an electric field. And magnetic permeability is the tendency of a magnetic field to arise in the material in response to an external magnetic field. Now, by adjusting the spacing and size of the elements in the metallic medium, a material's electric permittivity and magnetic permeability can be tuned into a desired value. And by tuning both to a negative value, a material with negative refractive index can be created. The refractive index is a measure of the bending of a ray of light when passing from one medium to another. In normal diffraction, with positive index materials, light entering the second medium bends towards or away from the normal, which is an imaginary line perpendicular to the interface at the point of incidence. However, when light passes from a positive index material to a negative index material, the light is refracted on the same side of the normal as the incident length. In other words, light is bent negatively at the interface between the two media. That is, negative refraction takes place. The unprecedented material properties provided by the metamaterials has led to the rapid growth of a new field known as transformation optics. In transformation optics, a metamaterial with varying values of permittivity and permeability is constructed such that the light takes a specific desired path. One of the most remarkable designs in transformation optics is none other than the invisibility cloak. Now, to wrap up all all the theories in this video, and to give a simple explanation, we can say that the invisibility cloak works this way. Light smoothly wraps around the cloak without introducing any scattered light and creates a virtual empty space inside the cloak where an object becomes invisible. So guys, that's it for today's video. We hope you liked it. Thanks for